to continue with exercise 12a of the chapter midpoints and its converse. We have already did till question number 6 in our previous video. Now let's do question number 7. Now in question number 7 we have a parallelogram ABCD in which L is a midpoint of AB and M is midpoint of CD. Now we have to prove this line DL and MB is going to trisect the diagonal AC. That is, DL and MB is going to divide this line AC into 3 equal parts. We have taken the intersection of DL and AC by the 2 points as X and MB with AC as Y. And we have to show this AX equals to XY equals to YC. Now for that, we can take the triangle ABY. In this one, we are having L as a midpoint of AB, but we need this LX parallel to BY. So for that, first of all, we are going to prove this BLDM as a parallelogram. Here we get AB equals to CD as opposite sides of parallelogram, and as this AB equals to CD, therefore the half of AB will also be equals to half of CD. And we know the half of AB will be equals to BL as L is a midpoint of AB. So BL equals to the half of CD, that is MD. Now as we have proved this BL equals to MD, similarly we can prove this BL is parallel to MD. Now in quadrilateral BLDM, we are having one pair of opposite sides as equal and parallel. Therefore, this BLDM is a parallelogram. Now in triangle ABY, L is a midpoint of AB and LX will be parallel to BY as they are the parts of opposite sides of parallelogram. So in triangle ABY, L is a midpoint of AB, that is given. Then LX is parallel to BY as the parts of opposite sides of parallelogram. So by converse of MPT, we get LX bisects AY. So LX bisects AY means this AX will be equals to XY. Now as we have proved this AX equals to XY, similarly in triangle CDX, we can prove the CY equals to XY. So here we get similarly in triangle CDX, XY equals to CY. Now let this one be equation number 1 and this one be equation number 2. So from equation 1 and 2 we get AX equals to XY equals to CY. So we got AX equals to XY equals to CY. Therefore this DL and MB trisects the line AC. And here we get DL and MB trisect the line AC. Hence proved. Now let's move to question number 8. Here we have been given with a figure ABCD in which AD is equals to BC and the points G is a midpoint of CD, H is a midpoint of AC, F is a midpoint of BD and E is midpoint of AB. Now we have to prove that GHEF is a rhombus. Very first of all, let's take this AD equals to BC, which is given to us. And now in triangle ABD, E and F are the midpoints of the side AB and BD respectively. And therefore by midpoint theorem, we get EF equals to half of AD. Now as we have proved this EF equals to half of AD, similarly we can prove EH is a half of BC, FG is a half of BC, and also the GH is a half of AD. And here we get HE equals to half of BC, FG equals to half of BC, and GH equals to half of AD. Let this one be equation number 1, this one be equation number 2, this one be 3, this one be 4, and this one be 5. Now considering all the 5 equations, we get that all the 4 sides are equal to each other because they all are equals to AD or BC, and AD and BC both are equal to each other. So from equation number 1, 2, 3, 4 and 5, we get EF equals to HE equals to FG equals to GH. And here we get EF equals to HE equals to FG equals to GH as all of them are equals to either AD or BC, and both AD and BC are equal to each other. Now as all the sides of a quadrilateral are equal to each other, therefore it will be a rhombus. So here all sides of the quadrilateral are equal, therefore EFGH is a rhombus. Hence proved. Now let's move to question number 8. Here in this question we are having a parallelogram A, B, C and D, and the CQ is 1/4 of the line AC. Here P is being given as the midpoint of CD, and we have to prove this R is also a midpoint of BC. Very first of all, we are going to do the construction by joining B and D. That will be another diagonal which is going to meet over here as O. Now we know the diagonals of the parallelogram bisects each other. Therefore, this CU will be half of AC. And here we get CU equals to half of AC. Now from here, we can get the value of AC as 4CQ. And from here, we get the value of AC as 2CO. Now we can equate the values of AC from here. 4CQ will be equals to 2CO. Therefore, 4CQ equals to 2CO. Now we can put the 4 on the other side. This will become CQ equals 2 upon 4CO. Now on further solving it, this will become CQ equals to 1 upon 2CO. This means this CQ is a midpoint of CO. Now in triangle CDO, P and Q are the midpoints of the sides CD and CO respectively. Therefore, by midpoint theorem, we get PQ is parallel to DO. So as PQ is parallel to DO, we can also say that PR is parallel to DB. That implies PR is parallel to DB. Now in triangle CDB, we are having P as the midpoint of CD. This PR is parallel to DB. So we can use the converse of midpoint theorem to get R as a midpoint of BC. So here in triangle CDB, we are having the P as a midpoint of CD and PR is parallel to DB. We have proved over here. So by the converse of midpoint theorem, we get PR bisects BC and therefore we get R as a midpoint of BC. This was our first part of the question, and now we have to prove this PR is half of DB. Now to prove this PR is a half of DB, we are going to take the triangle CDB in which P and R are the midpoints of the respective sides. Therefore, by applying midpoint theorem, we will be getting PR equals to half of DB. Triangle CDB, P and R are the midpoints of the sides CD and CB respectively. So by midpoint theorem, we get PR equals to half of DB. Hence, proved. Now let's move to question number 10. Here, by the information given in the question, we have got the triangle ABC in which DEF are the midpoints of the respective sides. Then AE and DF are joined in which they intersect at O. Then BO and CO are also joined, and P and Q are the midpoints of the side BO and CO respectively. Now we have to prove this DPQF is a parallelogram. So very first of all, we will take the triangle ABC. So in triangle ABC, we have got D and F are the midpoints of the side AB and AC respectively. Now here in triangle ABC, we have got D and F are the midpoints of the side AB and AC respectively. Therefore, by midpoint theorem, we can get this DF is parallel to BC and DF is half of BC. So we've got the side DF is parallel to BC and is half of it. Now we'll take the triangle BOC. In the triangle BOC, we've got P and Q are the midpoints of the side BO and CO respectively. Therefore, we can apply midpoint theorem over here too, and we'll be getting PQ is parallel to BC and PQ is half of BC. And here we get in triangle BOC, P and Q are the midpoints of the side BO and CO respectively. Therefore, by midpoint theorem, we have got PQ parallel to BC and PQ equals to half of BC. Now let this one be equation number 1 and this one be equation number 2. So from equation number 1 and 2, we get DF is parallel to PQ and DF is equals to PQ. And here from equation 1 and 2, we have got DF is parallel to PQ and DF is equals to PQ. As DF and PQ both are parallel to BC and DF and PQ both are equals to half of BC. And as one pair of opposite sides are both equal and parallel, therefore this quadrilateral DPQF is parallelogram. Now let's do question number 11. Here in this question, we are having a triangle ABC in which P is a midpoint of BC. Then a line parallel to AC is drawn from P as PQ, and then from Q there is a line parallel to BC from Q to R such that this R is lying on a line AP. Now we have to prove this AP is twice of AR, that is R is a midpoint of AP. Very first of all, we will be proving this Q is a midpoint of AB by using converse of midpoint theorem in which P is a midpoint of BC and PQ is parallel to CA. Now here in triangle ABC, we've got P is a midpoint of BC and PQ is parallel to CA. Therefore, by converse of midpoint theorem, we've got PQ bisects AB, that is Q is midpoint of AB. Now we've got the Q as a midpoint of AB and we know this line is parallel to this one. Therefore, we can apply again converse of midpoint theorem by which we will be getting this QR is going to bisect this line AP. That is, this R is a midpoint of AB, or we can say this AP will be twice of AR. And here in triangle ABP, we have the Q as a midpoint of AB and QR parallel to BP. Now, by converse of midpoint theorem, we get QR bisects AP, and therefore this AR will be half of AP, and on doing the cross multiplication, we get AP equals to twice of AR. Now we've got this R is a midpoint of AP, and we have to prove BC is 4 times of QR. Very first of all, we'll be proving this QR is half of BP, and as BP is half of BC, then this will become the 4 times of QR. So in triangle ABP, we have got Q and R as the midpoint of AB and AP respectively. So by midpoint theorem, we get QR is a half of BP. Now we know this AP is a median, therefore this BP will be half of BC. Therefore this BP equals to half of BC because of AP is a median. Now we can place the value of BP over here, and on doing so we get QR equals to 1 upon 2 into 1 upon 2 BC. That is 1 upon 4 BC. And on doing the cross multiplication, this will give you BC equals to 4 times of QR. Hence proved. Now let's do question number 12. Here in this question, with the information given in the question, we have got a trapezium ABCD in which AB is parallel to CD. Then we are having P and Q, the midpoints of AD and BC respectively. Then this BP is produced to point E, which is also lying on the CD produced. Now we have to prove this P is going to bisect the side BE. For doing so, we are going to prove these two triangles congruent. So in triangle BAP and triangle EDP, this AP will be equals to DP as P is a midpoint of AD. Then this angle will be equals to this one as vertically opposite angles. So angle APB equals to angle DPE, vertically opposite angles. And this angle will be equals to this one as interior alternate angle. Let this one be angle 1 and this one be angle 2. So angle 1 equals to angle 2, interior alternate angles. Now to prove these two triangles congruent, we have used this angle, this side, then this angle. So it is ASA. Therefore, the triangle BAP is congruent to triangle EDP by ASA. Now we can prove BP equals to EP by CPCT. And here we get BP equals to EP as CPCT, and therefore this P bisects BE. Now we've got the P as a midpoint of BE, and we know this Q is a midpoint of BC. So the line joining PQ can be parallel to EC by applying midpoint theorem. Now in triangle BEC, we get P and Q are the midpoints of the side BE and BC respectively. Therefore by midpoint theorem, we get PQ parallel to EC. Now as this PQ is parallel to EC and we know AB is parallel to DC, therefore this will also be parallel to this one. Now also AB is parallel to DC, which is given to us, therefore this PQ will be parallel to AB, hence proved. That's all for this video. Thank you.